Welcome. So far we had a look at the symmetry key encryption algorithms, and today we'll have a look at the asymmetry key encryption algorithms. Diffie Hellman algorithm. Okay, in fact, the one of the foremost asymmetry key algorithms, usually known for the key exchange. It works on the public key infrastructure, obviously asymmetry key encryption. Two entities A and B. So for the example, we will consider as Ram and Rahim as the two people who want to communicate, and Ram wants to communicate with Rahim. So Ram has got a key pair, public and a private key, and Rahim has also got a key pair, public and private key. Now, Ram wants to communicate with Rahim. So what Ram will do is Ram will exchange his public key with Rahim, and Rahim will exchange his public key with Ram. So the private key of Ram and public key of Rahim, and private key of Rahim and public key of Ram, when they subject it to Diffie Hellman algorithm, it gives them a key. Assume this key is a K, and this K will be same as what Ram has generated using Rahim's public key and what Rahim has generated using Ram's public key. Now we are achieving the best of the throughput for the data and transit encryption using the symmetric algorithm. Let's recollect what we discussed. Asymmetric encryption is slower in performance, and symmetric encryption is faster in performance. Now we are using the asymmetric encryption to arrive at the symmetric key, so that we have a superior throughput between the sender and the receiver. Now all these things will work fine until we have somebody called as a man in the middle. Now there are different types of man in the middle: interception. So we have fabrication, we have sniffing, tampering, and replay. And what we are going to see here is the sniffing. It can also lead to a modification or interception, whatever it is. Now, Robert will wait for the communication to get initiated between Ram and Rahim. When Ram is going to exchange his public key with Rahim, Robert will intercept that. And Robert will send his public key to Rahim, spoofing it as if it's from Ram. Okay, and similarly, when Rahim wants to exchange his public key with Ram, Robert will intercept this, and Robert will spoof the identity as Rahim and send his public key to Ram. Now, Ram does not know the public key he has received is from Robert and not from Rahim. Okay, similarly, Rahim does not know that the public key he has received is from Robert and not from Ram. So Ram assumes the public key is from Rahim, and Rahim assumes the public key is from Ram. Okay. Now, when Ram is going to similarly, when Ram is exchanging his public key with Rahim, so the interception takes place, right? So actually, what happens is the actual communication between Ram and Rahim is intercepted by Robert. Okay, and he's going to either listen to your message or he's going to modify your message. Okay, whatever it is, he's actually going to do it. But the interception, the sniffing, not interception, sniffing. Sniffing is more towards the confidentiality, and modification is more towards the integrity part of it. And the the interception and the fabrication can also happen because when Robert is going to spoof the identity of Rahim and send the public key to Ram. Okay, Ram will think that he is communicating with Rahim, but he is actually communicating with Robert. Okay, so fabrication can happen, fabrication can happen, and interception can also happen. When Ram is going to exchange the key with Rahim, thinking it's Rahim, Robert can intercept. Okay, so Robert can intercept the message. Robert, which is going to be actually a problem with regards to availability. And Robert can also sniff the message. So that is a challenge towards the confidentiality. Robert can also modify the message, which is going to be towards the integrity. And Robert can also do a replay. He can assume the identity of Ram or Rahim, and he can do it. So it's an impersonation. So that's a fabrication. Now, what is the replay? So Robert can listen to the conversation between Ram and Rahim that has happened earlier. Okay, and he can try to fabricate the entire communication. So all parts of the all different modes or all different types of man in the middle is actually possible this way. Now, if you're going to establish the authentication, okay, for Ram, Rahim, or whosoever is going to be a part of this Diffie Hellman algorithm, this man-in-the-middle attack can be avoided. So that's on the Diffie Hellman algorithm. So thanks for watching this. And next we are going to have a video towards your RSA. Stay connected, subscribe to my channel. Happy learning.